This segment is simply designed to assist or demonstrate, I should say, choosing the correct t-value from the t-table. So if you want to work along with me, go ahead and print out a copy of the t-table. I've made a fresh one here, although it's really not all that fresh because, as you can probably guess, my book has been written in because I grabbed a used book. But anyway, this segment is simply about demonstrating choosing the correct t-value from the t-table. And as a refresher, the t-values, the central portion of the table, the t-values are simply how much standard error we could expect to occur by chance given certain conditions. What are those conditions? The size of our sample, or more specifically, the degrees of freedom and the task at hand. And what's the task at hand? The building of confidence intervals. So, imagine, if you will, or assume the following information. In fact, I scribbled this out very quickly, but I'm going to number these just so I can refer to them. I did not upload this on Blackboard, but I just am using this as a demonstration. Assume the following. Sample size of 20, n equals 20, and that you were asked to build 95% confidence intervals. So n equals 20, 95% confidence intervals. Well, let's look at our table. If n equals 20, what's the degrees of freedom? N minus 1, 20 minus 1, that's 19. That means that our correct t-value is going to come from this row labeled 19. What's the task at hand? 95% confidence intervals. That's right here. 95% confidence intervals. That's the column from which the correct t-value will come. So I just need to find where those two things intersect. You go ahead and do that too. N equals 20, or 19 degrees of freedom, and 95% confidence intervals. I'm going to circle it on my table, and hopefully I'm correct. Hopefully you're correct. In fact, I'm even going to highlight it as well. 2.093. The correct t-value is 2.093. 19 degrees of freedom and 95% confidence intervals. What does that mean? That means that assuming, this is very important, assuming a sample size of 20 and 95% confidence intervals, we can assume 2.093 units of standard error to surround the mean. Let's do another one. Number two. N equals 25, 98% confidence intervals. N equals 25, 98% confidence intervals. Go to the t-table. N equals 25, that means degrees of freedom equals 24. That means the correct t-value is going to come from the row labeled 24. The task at hand is 98. I think that's correct, right? Yeah, 98% confidence intervals. That's the column that the correct t-value will come from. So let's find the correct t-value. Degrees of freedom of 24, 98% confidence intervals. The correct t-value would be, if I'm correct, and hopefully I am since I'm the teacher, the correct value would be 2.492. What does that mean? That's a t-value. Again, that's units of standard error, amounts of standard error. A t-value of 2.492. That means assuming a sample size of 25 or degrees of freedom of 24 and 98% confidence intervals, we could anticipate 2.492 units of standard error to surround that mean. Let's do another one. Number 3. N equals 10, 80% confidence intervals. N equals 10, which means degrees of freedom equals 9, and 80% confidence intervals. The correct t-value is 1.383. Let's do a fourth one. N equals 30. N equals 30, 99% confidence intervals. N equals 30, so degrees of freedom equals 29. And I'm assuming that we're going to calculate 99% confidence intervals. That means the correct t-value is 2.756. We would anticipate, or we could anticipate, 2.756 units of standard error to surround a mean that came from a sample that was n equals 30 and also had 99% confidence intervals. Last one, and then I'm going to move into drawing how we would draw these up. Last one, n equals 21, 95% confidence intervals. N equals 21, 95% confidence intervals. That means degrees of freedom equals 21 minus 1, n minus 1. 21 minus 1 is 20, 95% confidence intervals. The correct answer is 2.086. Right there, 2.086. Okay, I'm going to upload this item, and then the next item, also very important, is about how this information that we just went over, these 5 examples. So if you want to pause this and write that down, that might be a good idea, because we're going to use this information in the next demonstration. N equals 20, 95% confidence intervals. N equals 25, 98% confidence intervals. N equals 10, 80% confidence intervals. N equals 30, 99% confidence intervals. N equals 21, 95% confidence intervals. So I'm going to upload this, and then the next segment is going to be about drawing, how this would look on paper.